Hi, everyone. Good morning / afternoon for those on the East Coast or even further east. Thank you so much for joining for this webinar. The world is kind of chaotic right now, so just wanted to say super appreciate you taking the time to be here, learn about some of the work that we're doing at Verta. And from our side, we promise to make this super valuable. Our goal is going to be to do two things. One is tell you more about model versioning, why you should be doing it, and how we've solved the problem with our open source system called ModelDB. And secondly, we're going to do a hands-on walkthrough so that the moment you leave from the webinar, you actually have something that you can go and play around with or share with your team if it seems like a good fit. So with that, let me get started. We have a packed agenda, but we'll try to make it as interactive as possible. The main chunks are a model versioning overview and then a hands-on tutorial. As Julia mentioned, we want to keep this interactive. Since we're not doing in-person meetups, we've decided to continue the conversation on Slack so that folks don't need to get everything answered right away, or if they need help afterwards, they still have a place to go. So that's our agenda for today. And let me start with a quick poll on who's in the room. So you should be seeing the poll in your window. So it should show something like this. If you could just put in kind of where you're coming from, it'll help me gear the level of detail that I go into in the following slides. Okay. Awesome. Thanks so much. Here's who we have in the room today. We have a lot of data scientists and then a breakdown of ML infra engineers and data science managers. If your role isn't covered, would love to know what you do on Slack. Maybe that's a longer conversation. Awesome. All right. So thank you for that. So for the rest of the talk, I'll focus more on how, as a data scientist, you can leverage the capabilities of an open source system and how you can version your models going forward. Great. So let me do a quick intro of myself and the team who are helping me here today. So about me, I did my PhD in CS from MIT, and I was the original author of ModelDB. This was a project from MIT whose goal was to version and manage models, particularly ML models. And this was the first system ever built of that sort. And we're really glad to see that other research and commercial systems have picked up those ideas, and we're seeing a lot of wide adoption. So after ModelDB, I founded the company Verta, who I'm here representing. And we're a small team in Palo Alto where we build ML infra tools, particularly around ML ops, which is versioning, deployment, and monitoring. I have two of my teammates here who are going to be assisting with answering questions. You'll see Ravi as well as Michael on the Slack channels, and I might ask them to field some of the questions towards the end as well. So that's a bit about us. You can look us up on Verta.ai if you want to learn more, but let's get started. So I will put this link up here. It's also sent in the chat. This is a hands-on webinar, so the setup instructions are on that link. I'll give folks just a minute in case they're trying to type it into their browser bar. Wonderful. Okay, Julia, if we could send that over in the Slack channel again and in go to webinar, I'll keep moving. Awesome. So model versioning overview. All right, so we're here to talk about model versioning and ModelDB. Let's dive in and level set on why we're doing this at all. And most folks here are data scientists or ML engineers. So if you look at Kaggle, this was some research we did back at MIT where we looked at the number of submissions per competition in Kaggle. So toxic comments, the price suggestion, iceberg classification, you name it. And what we were curious about was how many iterations does a data scientist go through before they find a model that works well for them. And the key point here is to see the numbers are always in double digits, but many of them are over 100. So these top contenders are actually making hundreds of submissions on Kaggle before they identify a model that works. As data scientists, we've all done this. The number of models we build is not just 100, but it's often in the thousands because these numbers don't capture the hyperparameter searches that we might be doing or experiments that don't work out and as a result don't make it to a submission. So that's how many models get built on a per project basis. However, we all know that our model development is very empirical and it's very ad hoc. We try a bunch of things. We start off with a simple looking model. We add a few pre-processing steps there. We change the type of model we're running. We do a hyperparameter search. And by the time that we get something that works, our code looks nothing like what we started off with. So this is, just normal. You might argue that with code, this happens a lot too. What's different with models, though, is every exploration that we do, every model that we're building actually informs the final model, or it is essential in even answering a regulatory question around why did you pre-process the data in a particular way, or why did you pick this particular model over another? So unlike code, where you only care about the last final endpoint, in models, we actually care about all the iterations that we went through. In spite of that, the state of the art in model versioning is, of course, our beautiful folder system. This is a screenshot of my my Mac folder system at some point. Or it's these really strange comments that we've seen on Kaggle. So this is someone who's keeping very close track of all the experiments that they're doing, but they need to do that in comments because they can't really do that very effectively in a centralized versioning system. Of course, sharing our models is still challenging. PyTorch Hub and TensorFlow Hub are changing this a little bit, but yet we keep shipping our notebooks around in order to share our models. And the key point I would like to make here is these models are going to be powering our self-driving cars. They're powering the models that are being used to detect, say, lung diseases in patients. And so we need guide rails as well as more robust systems to do model versioning. So why is this a problem? Before we go on to the solution, let's crisply articulate that because we as data scientists get asked this question a lot. It's like, why is this important? The first one is just for us, scientific rigor. How do I reproduce my work, or how do colleagues reproduce this model that I built? And as we start reusing models built by different organizations, this is going to become an even more important consideration. If you're putting models into production, just like you always want to know what version of your code is running, you want to know what version of your model is deployed. Suppose the model is breaking and you need to roll it back. You ought to know this is the particular version that I've deployed. This was the previous version. And so you can always go back to a stable state that you have known. The third one is speed of delivery. This is more on the DevOps side. If you want to automatically package or retrain your models, then having a model repository or a versioning system becomes essential. For the managers in the room, you're going to have churn in your teams. How do we preserve the knowledge when folks leave the team and they were working on a project, suddenly someone else needs to pick it up, and we don't have a good history of what happened during the time that they're working on this project? Finally, for data scientists, it's just a sanity check. What experiments have I run? What is missing? If we don't know where we're coming from, we're going to have a much harder time figuring out where to go. So if you think about why you need versioning, the motivation for having a system to do robust versioning is very, very large. And yet we're finding that given how young a discipline data science is, we're still at the beginnings of building these types of components. All right. So we've established that we need model version control. Let's get on the same page regarding what do we mean by model version control and what are the key operations that a system must support. So the first one, if you think about Git, and we at Verta and ModelDB have been heavily inspired by Git. One of the main things that a version control system gives you is the ability to manage changes over time. Just like in your Git log, you can see all the changes that were made to a branch, that were made to a repository. We want the ability to see what changes happen to a model over time. We want the ability to go back and to see what diffs were added, who made those diffs to, and we want immutability. So once you say that I built this particular model, you shouldn't be able to go back and change the way or change the definition of that model. You need to create a new one. The second one seems rather simple, but is super important. We want to uniquely identify a model. So it's not good enough to say this model is a ResNet with this particular size. There's a lot more that goes into the final checkpoint or the final weights that you obtain. So what we want to do is to have a snapshot or a Git SHA equivalent for models so that we can go back, reproduce this model, and also provide a level of governance. Last one is, just as GitLab and GitHub have enabled us to collaborate, we want the ability for multiple data scientists to work on the same project without conflicting, to pick up the best feature pre-processing that your colleague might have done, and then combine it with your best hyperparameters that you have found in your exploration. So that's what we want to get out of model version control. And it's interesting that we're now at a point where version control systems for code have been around for over 30 plus years, 50 years. My math is a bit off this morning, sorry. 50 plus years, and Git is actually turning 15 this year. So it actually takes a bunch of different iterations to get these systems right, and we're glad to be contributing to that. So with that, let's dive in. We want to build a model versioning system. We're going to architect it. What should we version? It sounds like a very simple problem, but we've been through a lot of cycles figuring out what all should we version. And let's draw a parallel to software. So in software, we have code that gets built into a binary, and then that gets Dockerized most frequently these days so that you can deploy it on Kubernetes. What we care most about versioning is our source code. If you have the source code, you can always go to the binary, you can always go downstream. But if you have the binary, you cannot go backwards. And so the key point here is you need to version, as we call the ingredients, of the artifacts you want to build downstream. For models, similarly, we not only have code, but other inputs or ingredients that I'll go over. These produce the weights or checkpoints, and these produce the containers. So drawing a parallel to software, the thing that we want to version are these basic constituents, including code, data, etc. So in our system, we have taken the approach of always versioning the ingredients, knowing that we can reproduce the weights and checkpoints. You can save these weights and checkpoints as artifacts, but they're not part of the model version itself. And I'll go through an example later so that this becomes crystallized, but abstractly, that's what we're doing. Now, I just said that we want to version the ingredients of a model. What are they? This should be pretty straightforward. We have the code itself that is producing your model. We have your configurations, and note that this is separate from code because your code might do a hyperparameter search and you wouldn't know what combination of hyperparameters actually produced the model that you're looking at. So that's configuration. Third one is data. Data is so essential to everything that we do, and we want to version the data as part of versioning the models. And the last one is environment. Working in Python, in particular, library versions are a bane of many people's existence. And so capturing the version of libraries, capturing the hardware is what we combine into our environment version. So those are the 4 ingredients of models. And throughout the rest of the talk and in the system walkthrough, I'll show you how we use them in interesting ways. So that's what we mean by versioning. There's a lot of folks here who are kind of friends from other projects that have been working on metadata, experiment management, versioning. So I do want to lay out how we think about these related and yet distinct concepts. So at the bottom of the stack here, we have versioning. This includes versioning the ingredients that produce your model. And our goal here is really reproducibility. We want to uniquely identify a model, track change, be able to go back in time and reproduce a particular model. Once we have that base, then we can add metadata to it. And metadata can encompass a lot of things. So that's where we initially started with ModelDB and quickly realized that we had to go a level deeper in order to provide the kind of robustness and guarantees that we wanted. So with metadata, the things that we track can include metrics. How well is my model doing? Perhaps you have an ROC curve that you want to associate with a model. There might be organizational data, like what team created it, what team owns the model, what user created it. You might want to do searching, sorting, and the like. So the things that you would capture in metadata sometimes can overlap with versioning. For instance, hyperparameters are often captured as metadata. However, metadata can tell you a little bit about how the model came about, but it's not going to let you reproduce the model in the same way that the versioning system can. So metadata is great, but if you want robustness, we need to go a level deeper and also augment that with a solid versioning system. The top of the stack is what can you do with this information? So this includes things like experiment management, where you're tracking the experiments that you're doing, maybe you're writing reports. It also includes compliance, it includes collaboration. So as you think about in your team or in your work, what is the right type of tool that you want to use in your workflow, the question to ask is, what are my goals? Am I looking for reproducibility? Am I looking for analytics? So we've chosen to support versioning as well as metadata a bit because of our history, and then you can build a host of these applications on top of it. And I'll show you more about that, but wanted to lay out how we think about these concepts at ModelDB and at Verta. I'm happy to talk more after. I'm sure folks have questions about this too. Great. So let me pause here and see how we're doing. I'm gonna do a quick poll before I keep going. The next set of slides are gonna be architecture slides. So this is making sure we're all on the same page. Perfect. All right, everyone is on board, so I'm gonna keep going. Great. So I laid out why we want to do model versioning, how we think about metadata versus versioning. Let me dive into the architecture that we've set out for our system and how that translates, what are the abstractions, etc. So a bit about ModelDB, who are not familiar with it. The first version of this project at MIT was metadata focus, so the second layer that I just showed. And we managed hyperparameters, metrics, metadata, tags, things like that. And a big ask that we got from users was, I want to go back and exactly recreate something. How do I do that? So at Verta, we've been building ModelDB 2.0, which is really focused on versioning. We're heavily influenced by Git, and yet we're different, as I'll show you. Metadata still exists as a first-class construct, and we've built out a bunch of integrations into both MLOps as well as frameworks that are most frequently used for modeling. So let me preempt this question because it's a very important one, and we thought about this hard. Why not just use Git? Git is amazing for code. We all use Git, and it's been made robust over a decade of development. There are a few things that are unique about ML, which is why we cannot use Git. And I would expand that to any sort of data analytics, not just ML. The first one is Git doesn't handle large files well. So if your data is multiple gigabytes, Git is not the right place to store it. Git LFS maybe, but most of our systems store data on S3 or in databases, and those don't interact well with Git. The second one has to do more with the ML workflow, where a lot of data scientists are not working at the command line, they're working in their Jupyter notebooks, and whatever versioning system we adopt needs to be accessible as a library, along with being accessible as a command line. The next one is Git as a distributed version control system, which means anyone who downloads a repo needs to get all of its history. Now imagine doing that when you've built 1 million models in your company. That's just a lot more challenging when you expect multiple people to be collaborating on the same project. And finally, going back to the way that ML models are built, even though some models may not make it to, we build thousands of models, and yet only one of them makes it to the top one. We still want to track all of the experimentation that happened outside in order to be able to justify our choices in modeling. And so that's where all the commits or branches that we're used to in Git need to be preserved, as opposed to just preserving the last and final commit. So those are some of the reasons why we chose to build a system that is heavily influenced by Git and yet is a little bit different. So let's dive in and see how we actually ended up architecting the system. The abstraction here is that ModelDB is a, let's call it a super repo. So just like you have a Git repo, ModelDB has its own repo. It has a lot of the same APIs that you would expect from Git. However, what ModelDB does is internally, it has a set of repositories for the different ingredients or constituents of the model. So we have a data repository, we have a code repository, environment, as well as config repository. And what we've chosen to do is all the operations that are specific to data or code or environment get delegated to the repositories that actually handle these types of abstractions the best. So what that means is for code, we use Git. We're not going to reinvent that. For data, we still don't have a good way to version data. If your company has a good feature store, maybe that's what you want to plug into. Maybe you have a homegrown system. So what we've done is where systems don't exist for robustly versioning these types of ingredients, we've built lightweight systems of our own. So for instance, one way to configure a ModelDB is to say that you're going to use Git for your code versioning as well as your environment versioning, but you're going to use Git for those two, and you're going to use ModelDB for data and config. Suppose your company has a feature store. That's great too. All you need to do is you need to use your feature store as opposed to ModelDB for your data repo, and the other components can again be very flexible. So the idea here is similar to Git submodules for those that are familiar with Git. We have the high-level repo, and then it's going to delegate all the operations to things that are more specialized for handling that type of data. So that's how ModelDB is structured at a high level. Concretely, what does that mean? So we're going to go through a census example in just a couple of minutes. In that case, in the census repo, what we have, the census ModelDB repo specifically, what we have are subrepos for the training data, for the code, for the config and environment. And each of these repos, we have a SHA or a unique ID that is tracking the version that is used. Now, you're not limited to the 4 ingredients always. Maybe you have 2 different kinds of data, you have 2 different kinds of code, and you can pick and choose the versioning systems that you want to use for each one of them. The advantage, so let me come back to that. The advantage of having a super repo is that if you wanted to do an operation like a revert on the ModelDB repo, it's extremely simple to just ship that to the appropriate component. So maybe you need to do a revert on Git or on your data repo, environment repo, or config repo. If you need to do a merge similarly, then you can delegate that operation to these constituent repos. So that's why we chose to have a central repo that would bring together these different kinds of versioning systems and capture something that is best of breed. So let me go back here and explain how to reconstitute a version before we go on to the hands-on part of the demo. So you have a version that has been logged into ModelDB. How do you use it? So there are also APIs to do this, but at a high level, what you're doing is you're checking out the ModelDB commit. Once you check that out, that is equivalent to checking out your Git commit. That's also equivalent to checking out the version of data that you use to create the model. And then you can either use Docker or some other system that you have built in order to train or retrain the model. So that's one example of how you can use the versioning system to reconstitute or reproduce your models. But we found that this is very specific to your particular workflow, and happy to talk through how this fits into your setup a little bit later in the talk. So that's a quick overview of what the ModelDB interface looks like and how we've structured the system. So next, we're going to go through a hands-on exercise. So let me do a quick pulse check again so that we are good to go. Okay. So for the hands-on tutorial, let me get a sense of whether folks have already set up the ModelDB system or whether I should walk through some of the details there as well. Just checking in to see if there are any questions on the community channel. Okay, so it looks like we have a distribution of folks. A lot of them seem to be done. A few people are getting started. So what I'll do is I'm gonna pull up these instructions that I had shared before. And I'll walk through them very quickly. That's the Slack channel link. To do the rest of the webinar, you'll need a couple of things. You need to use the ModelDB server. Here's how you set it up using Docker, so locally you can run this. We recommend using this approach because even after the webinar, we want you to be able to use ModelDB. There's an AMI too that you can use. For the purpose of this webinar only, we've set up a hosted AMI. So we will be taking this down a couple of hours after the webinar. So you can try it out right now, but we don't recommend using it long-term because it will be turned down shortly. So that's your ModelDB server. The next thing is to install the ModelDB client. This is a Python library. You can use pip, you can use conda, whatever your preferred option is. And then the notebook that I'll be walking through is this particular one that's linked here. And the notebook goes through the census example that, that I mentioned earlier. So let me pause here for a couple of minutes, and my team and I will try to help as many people on the Slack channel. So feel free to put your questions in the chat area, or feel free to put them on Slack as well. So for those who are already set up, you can start looking through this notebook. You can also start running it. I'm gonna give the other folks just a bit of time to catch up, and then we'll keep going. Note that if you're using the AMI, then the hosted AMI in particular, then you don't need to do anything special to make the demo work. I need to run my Jupyter notebook. Give me a second. All right, if you're using the AMI from Amazon, you don't need to do anything terribly special. You'll just need to change the host to the URL that's mentioned in this particular set of instructions. All right, I'm gonna do another poll to see if we're good, and then we can keep going. It's just gonna be a yay or a nay. So if you're set up, just you can respond with a yay. Otherwise, you can respond with a nay. Cool. All right. Looks like a lot of folks have been able to set it up. So let's keep going. If you do run into issues, then please use the Slack channel. And for now, you can just see how I'm using the system for doing the different operations. All right, perfect. Let's get into this. So this is a notebook. I'm assuming everyone here knows Jupyter. So just pull up the notebook that is Census S3 OSS versioning. This is what the notebook should look like. And what we're gonna do here is we're gonna build a couple of simple logistic regression models using scikit-learn. And we're gonna show how to version those models and also use metadata to track extra information around it. So you'll get a good sense of where is versioning useful, where is metadata useful, and then you can use this offline too. Awesome. So what I'm gonna do here is you're importing Verta, nothing super special going on there. Let me make sure I have cleared everything. Great. So importing Verta, make sure you're on version 0.14.2. That's the latest one that I'm using. And then here, what we're doing is we're just telling it that our host is localhost 3000. If you're on the Amazon, the hosted Amazon AMI, make sure that you're putting in the URL for that AMI here. And we're telling it that we're working on this particular project, which is the webinar. And this is the census income classification. I gave it an experiment name. I'll show you where that becomes relevant as well. I have a bunch of imports here, your regular, NumPy, scikit-learn, pandas, and so on. And then wget so that you can actually fetch the data from S3 that we're gonna be using. So a bunch of imports, all looking good. Here we start with, and we start interacting with ModelDB and Verta. So I am initializing a client that is talking to the server running on board 3000 in my case. I'm setting a project. I'm also setting an experiment. Now, here's where the versioning and the repository component of ModelDB comes in. I'm saying I'm working on a particular project, which is a census demo, and I want you to associate that with a new ModelDB repository. The name of that repository is webinar, and I want to essentially create a branch that is called logistic regression so that I can log all of my models and commits there. So I'm gonna go off and I'm gonna create this particular branch, which is the log reg branch. I here got the master branch and then I forked off to create the log reg branch. Happy to discuss the APIs a bit after. I want to make sure I go through the end-to-end and then take questions. So now I'm on the logistic regression branch. Next thing I'm going to do is I'm going to go and register some of my models and version them. So let me prep my data. I'm creating some data here. So I have a couple of files on S3, and I'm creating a dataset version. So this is using ModelDB's internal data versioning system. If you have another versioning system, then we can talk offline on how to plug that in. But for the purpose of this webinar, we're going to be using just the ModelDB system. So prepping the data, downloading it. This is what the data should look like for you. It's tabular, and we've pre-processed it so that we can focus on the modeling itself. I'm defining a hyperparameter grid that I'm going to search through. And here is the function that actually trains my models. So this is where the interesting stuff is going on. So let's dive a bit deeper. When you're running an experiment, the first thing that we recommend doing is version your ingredients. So versioning your code should not be an after step. Once you've done all of your experimentation, then you're going to go back and version the ingredients. What you want to do is you want to version them before you even start training your model. So here I'm saying I have 4 ingredients. I have my config version, which is just my hyperparameters that I've defined. I have a training data set, which is coming from S3. I have a test data set that is also coming from S3. And I'm in a Python environment. So I'm telling the ModelDB system that given it's Python, please pick up the dependencies as appropriate. So I'm going to go get that information, and then I'm going to create a commit that has all of this information stored within it. So it's going to store the code version, it's going to store my hyperparams, it's going to store my data sets, and it's going to store my environment. So at this point, I have created a commit similar to Git. In Git, you're adding files and then you're saying commit. So that's what you're doing, except you're doing it in real time in an API fashion. And as usual, you can add a commit message. Some funny things happen here because I'll show you why I say that. That's because we do experimentation in kind of staggered bursts, and that leads to interesting commit messages. All right, so I've created a commit. I'm going to go off and I'm going to train my model. So I'm doing a train test split. I am then going to actually fit the model, simple logistic regression, nothing fancy. Then I'm going to also compute the validation accuracy, and I want to store it as a metric in ModelDB. Finally, I've chosen to store the model itself. So this is helpful if your models take a long while in order to train, and that's where you want to store the ultimate outcome as opposed to only storing the ingredients. So you can do that, version code. And finally, what's going on here is the commit that I created up top, I'm associating it with the run object here, saying this particular run was created by this particular commit. So let me go ahead and run a bunch of these things. So that's going to go off and create several experiment runs and models, and it's telling me it's going through all of the components. So let me show you what you should be seeing on your local machine as well as on Amazon if you're using the AMI. So if you're on the local machine, by running through all of these steps, you should be seeing this particular project called Webinar 1 Census Income. If you click through, you're going to be able to see different things. For instance, and you can go and play around with this as much as you like. You can add a description here. You can add tags here like, hey, this is my demo. You can add a readme.md here. The part that we're going to be concerned about here is the experiment runs. So you can see all of the models, and I have a few more since I've been playing around with this for a bit this morning. You'll see all of the experiment runs that were created when I just ran this particular notebook. So my notebook cell has finished running. What it has created for me are, let me just refresh to make sure I have the latest. It has created for me these 4 experiment runs. And let me click through there so you can see what that looks like. So this is an experiment run. And what it's telling me is, first of all, this run was created from the particular ModelDB version captured below. So it's telling me what my repository was, what my commit SHA was. So if at any point you wanted to go back to a particular version of this model, you could just go back to this commit SHA. It's telling me what were the ingredients of the model itself, including the hyperparameters, the notebook, Python environment, your data, etc. So in this particular example, I chose to both log my information as a version and also as metadata so that you can see clearly how they're different. So I've logged the hyperparameters here. I've also logged code version and some metadata about datasets. Now, the funny thing about metadata is you can't tell what version of the model came from which other. So for instance, if you go here, there is no historical information that particular model 1 was derived from particular model 2, and maybe that one was derived from model 4. However, if you go to the repos tab here, you're going to see the repo that we're working on, and we're currently on branch log reg. If you look at the history, you can actually see all of the experiments that you just did or have done previously. It'll tell you what experiment or what model was derived from which parent. If you click on any of these SHAs, it's also going to tell you what changed between them. So it's telling you that there was something different about your notebook, and it's identifying that. It's telling you that the hyperparameters were different. And at the bottom, it's actually going to tell you what run was created from this version. So it's not just that this version was created from this run, but you can go the other way around as well. If you only track the metadata, it's extremely hard, as we found out the hard way in some ways, to have this history, to have a immutable set of changes that you made and have the ability to go back and see, oh, hyperparameter tuning run 0. What exactly did I use there? What were my hyperparameters? Oh, I see, those were my hyperparameters. I can go back and see what my environment was like. Perhaps the version of a particular library turned out to be quite different. And this is an easy way for you to keep track of all of those. I mentioned earlier that something funny happens when we give names to our commit messages. Now, in my code, I just had a loop that was assigning an index to each one of my hyperparameter searches. We're not always very wise about what to call our models, and so a bunch of these say the same thing. So what we do is we provide a unique ID so that users don't need to come up with a unique ID. And now instead of saying, oh, I'm talking about the model hyperparameter run 0, you can just say, hey, I'm talking about the SHA, which is 70C7, blah, blah, blah. And your colleague or even your future self can go back and know exactly the configuration that was used. All right, so that's the versioning component. As with branches, you see the logistic regression branch, the master branch. You can do comparisons too. So if I'm on these two branches, I can see what changed in my code itself. So it's telling me the hashes are different. I was on a different branch here. My hyperparameters were different. Everything that you can do with Git, you can also do here. So that's what versioning gets you. Let me show one last feature on versioning, and then I will also highlight other sort of metadata things that you can do with ModelDB. So I'm switching back to the Jupyter Notebook. At this point, I have a bunch of commits that I've added. You can see what commits were applied, pretty simple. Now, as it happens with coding, you're going to make some mistakes and you want to change where your master branch is. Essentially, you pushed the wrong commit. You want to go back and revert it. All good. You can just say revert this particular change. Similarly, perhaps I'm working on a particular change in feature processing. Michael from my team is working on a better model. In that case, all I need to do is get his branch, get my branch, and merge them. For this example, what I'm going to do is the following. I'm going to pull the master branch, and I'm going to merge my logistic regression branch into it so that now master is up to speed with everything that I've been doing. So that's it. You get the commit, you get the branch, and then you merge them. you can see the changes that happen on the web app. So if you look at the history, you'll see that I just merged logistic regression into master. And this lets me pick and choose the components that are most relevant from different branches and pick the best model, so to speak. And there are various things related to merges and conflicts that are better for offline discussion, but at a high level, this is what a versioning system can really enable. As a final thing for me to demo here, I have talked a lot about the versioning capabilities. On ModelDB, we really started with also metadata and making sure that ModelDB was a rich interface for all the information related to ML. So things that you can get off the bat with the open source ModelDB are things like there's a comparison button here that you can check out. You can add tags to it. So this can be my best model. You can do searches based on these tags. You can sort based on metrics. And I'm a super visual person, so I really like looking at charts and seeing what trends I can see there. So if you just switch to the charts tab, you're going to be able to see different metrics, be able to graph it based on different categories here. You can build charts, you can build box plots. There's a lot of stuff to explore here. I won't be able to go through a super detailed tour, but when you're doing hyperparameter searches, this is what you can use, etc. And then finally, what we like to do a lot in our team is once someone is building a model, or rather working on a project, they build a dashboard and then they're going to share it so that a colleague can review their code, can review their results, etc. So what we have here is a way to not only log your projects and do experiment management, but having a versioning system is going to allow you to do things like share your projects more easily, make your models more reproducible, while keeping with yourself all the metadata components that made ModelDB v1 so interesting and useful. So that's all on the hands-on part of this particular session. So I've given you a very quick overview of what we do in ModelDB, our design decisions, and our architecture. We are constantly updating ModelDB in response to user feedback, asks, etc. So what we would ask of you is to try it out. If you're open source sort of nerd like us, then fork it. Let us know about interesting use cases that you're trying to solve for with ModelDB, because A, we would love to profile them, and B, maybe we're missing something that we need to add. Please give us feedback. Maybe there are things that we can change or do differently on the API. We would love to hear it. Maybe you're a really CLI person and you want to help us build out a really beefy CLI there. And we would love for contributions. This is open source for a reason. I think we're still figuring out how to handle these really hard problems, and that's where we'd love to get folks' feedback. We love talking about this stuff, so hit us up if we can do a tech talk or help you get set up. Everyone on my team is more than happy to do that. And we've been receiving a lot of requests for a hosted version of ModelDB. So if that is of interest, drop us a line. It'll help us figure out how to find the resources to make that happen. So here's all the contact info. There's a Slack channel. There's also Verta's ModelDB repo. My contact info is there too. We are actively iterating on the system, so would love to help you get set up with ModelDB and also help you use it. So please feel free to take us up on that. We want to get as many people doing model versioning in their daily workflow. So appreciate your time again. Stay safe, everybody, and hope to see you again in about a month when we run our next webinar. Thanks all. Bye.